On the last episode of the Cardboard Airplane Saga, we made a cardboard fuselage that I'm going to fly in, cardboard wings in the previous video. Now that we have this cardboard airplane body, it's time to add some electronics to it, mainly engines, controls, wheels, and these strappy straps to hold the wings on. We got the straps strapped in with hot glue and tape. Very, very, very sturdy. Now, I did talk about this, about jettisonable landing gear, because I think that'd be really, really cool for this airplane, because it doesn't really matter that it does takeoffs and landings in rows. We're not doing any touch and goes unless I'm just dragging the fuselage across the ground and then taking off again, which I'm hopefully not doing. So for that, we're going to be building a carriage. So we're basically going to be putting this together. I'm going to make a little kind of pin here that wraps around this piece of wood that I stuck in there, so that when I release the pin in the front, this pivots outwards, and then once it's facing basically straight down, it'll fall off. Ejectable landing gear. I have successfully crafted something that is actually probably more heavy than the cardboard airplane itself. So this is our jettisonable landing gear. We are going to be doing 2 phases of testing. One involves a high-speed taxi test where I make sure this is secured completely to the airplane and doesn't fall out. The second test is where I take off, climb to 10 feet, pull a pin, and release this whole assembly, and then really fly the airplane. Because this thing weighs... I don't know. Where's the scale? Today I weigh 150 pounds. And today this thing weighs 184 pounds. That's like 34 pounds. It actually weighs more than the empty cardboard airplane with tail feathers and everything. It's gonna fly better once I release this. It rolls pretty good though. That I release the pin, and this gravity just takes over. This falls out. This gets to the point where it's just out of the, it just like rolls itself out of the cam. At this point, gravity will take over, and this is just going straight down to the ground. And then we have no landing gear. Who needs landing gear? I've seen my fair share of people landing their own private airplanes, usually twins with retractable landing gear, where they don't put the landing gear down.
Keep going, you're good, and stop.
Now they're usually fine, but the plane itself is not so fine. Alright, we have an entire landing gear assembly that weighs more than the airplane. Let's put the airplane on it. This is honestly really funny how light this is versus how heavy this is. It weighs nothing. We're flying all along. Got our landing gear. It's kind of suspended with some string. That goes up around the fuselage. Probably fine, honestly. Who knows? Maybe if this thing gets hung up or something, and this tears out, now it's firmly stuck to the airframe, which is a little bit of a bad thing, because I prefer it all rip out, but maybe it'll just tear out. Who knows? I doubt it'll be that dangerous. We'll really find out. So we have this. My feet, I just move on my feet here for a brief second, and push. And the carriage drops away like that. So that was pretty solid, honestly. It didn't even need to rotate very far, it just fell off. You might be wondering, what is with this sled thing? Well, dear viewer, if you haven't been following me for a very long time, we actually did one of those man-flying drone things. Unfortunately, I kind of tied it to a Christmas video, so the algorithm didn't really pick it up. I don't know, YouTube just kind of hates Christmas, and maybe hates everything in general, especially season things. So this video didn't get that popular, but you should go check it out. I put my dad in it first. We flew around via RC, had a DJI flight controller, then I got in and flew it around. So yeah, it's a manned drone before they kind of got super duper popular, I guess, on YouTube. But back on topic, it has motors. The lift in this thing is pretty good. Like each of these is about 30 something pounds. 30, 60, 90, 120. 120 pounds of thrust. Now we are going to lose some of it. It's not really 120 pounds because we're using them in like a pull-push configuration, where this one's actually doing a little bit less work. Since they're the exact same blade pitch and size, this does a little bit less work. Doesn't matter. I think 120 pounds is more than enough for us to fly this piece of crap cardboard airplane. So I'm going to take this motor bar, we're going to slap it on that, and that will be our engine assembly. Oh, that frees up so much space up there. Now you can put more junk up there. Okay, we got the sled motor. This is going to power our dreams of flight. These have to be slipped on. The order of assembly. It's 2 layers of cardboard with this plywood. I'm sure this could take easily 100 pounds of pulling force without ripping out. And plus these are electric, so they're really, really smooth, so I'm not worried about vibrations. If this was gas, ooh, we could lose the motor, especially if it vibrates and resonates the airframe at certain RPMs. I'm glad I don't have to deal with any of that crap because the brushless motors are super duper smooth. The fuselage itself is canted a few degrees, probably just because of a poor quality control, but you know, it is cardboard. I'll take level motors though overall, so it's good enough. Every plane needs instruments, so therefore I have my old Pizza Hut dinner. Because this box looks perfect for holding my airplane instruments. So I've been working on this. We're going to use some Arduino. So now we have an indicated airspeed sensor. So we're going to mount this on the airplane, which I have to make a better enclosure for this. The next thing we need to install on the airplane is a breathalyzer to make sure blood alcohol content is high enough so you can fly the airplane. Because you've got to be kind of crazy to fly this thing. And I'm going to put the instrument inside of my pizza box. I'm going to mount this to the airplane. I also got to do an altimeter, so let's go work on the altimeter, and we can put all this together. I really don't know why I'm adding these instruments in. I mean, it's kind of funny to see how fast this plane's going. Plus, I do want to actually be able to play back some of the video and see exactly how fast and how high we were going. It literally makes no sense to do any of this. It's like, it's an ultralight. Like, if you need an airspeed, an altimeter, and an attitude indicator, cooked. You're totally cooked. Don't fly an ultralight. You just have to fly an ultralight by the seat of your pants. It's really the best way is to do it. All of my ultralights have been flown by nothing but feel. But I like the idea of having an altimeter stuck in a pizza box in the front of the airplane. This project definitely has tons of steps, from making the fuselage to the wings and now to the small details like this. It means there's tons to manage. It takes smart steps and planning for most of the projects on this channel to efficiently make good content, which is why I use Odoo to help streamline this process. Odoo is an all-in-one management software that provides users with a ton of tools for running your business, including accounting, invoicing, project management, inventory management, website creation, and much more. You can even get one app for free with unlimited hosting and support. I've been using this one for this build, which is the Project app. It's just like my whiteboard diagrams and allows me to populate the board and get a clear view of the steps and processes on any project that I'm working on. You can even break more complicated projects down to subtasks to keep things on track and make your deadlines. You can even collaborate in real time and share the project with an external or internal team. It's been helpful for keeping the cardboard airplane project condensed and concise. That means good collaboration between me and my editor to make these videos worth watching. Definitely check out the app for a free app of your choosing, or you can get all of the apps for $24.90 a month. Check Odoo out and click the link down in the description and help manage your business or projects today. Flight controls. How are we going to do this? I've noticed quite a few comments. We haven't really done the Q&A yet, but a lot of people were like, you should make it rate controlled and just get in and fly, or you should fly it rate controlled first, or you should just turn it into an RC airplane when you're done with it. All very good points. The big point I want to make is this. Yeah, let's crap out. So I get in the airplane, and it's such a tight fit. Not only do I have to climb around this control column, it's now I have more of my way. It's like, how do I get out of this thing easier if I have to get around the stick or if something gets mangled up? I also have to plumb this to go to the side of the airplane and do all of that. Now, I did think about this in another way, too. It's like, okay, maybe we isolate a few of the controls to just full manual with actual cables for feedback. So I was thinking maybe we just do the elevator only, and I pull back on this stick to take off and, you know, control pitch. Well, I don't really like that either, because now I have this complex thing of this stick, and I have to get my controller, and I was going to mount the controller to the stick, and I have to, like, fly the airplane with the controller for the throttle, the differential motor steering for the initial takeoff roll, and the rudder, but the elevator is mapped to this thing, so I have to teach my brain to do this to take off, which I'm not going to be able to do in a short period of time. I'm immediately going to start pulling back on the RC control stick because I'm thinking it's a big RC airplane and screw myself doing that. So let's just make the whole thing freaking fly-by wireless wire. So it's going to, rather than be like fly-by-wire like an F-16 or something, it's fly-by-wire wireless. Because we have wires that control the servos, and then we have a wireless connection to the back of the airplane, which is really stupid, But I'm going to try to make this thing as redundant as possible. I'll show you guys that in a minute when we build it. I can't wait to do this stuff. I'm getting a little ahead of myself. I really should just do the other work, because this is like not really that important for flying. It's an attitude indicator. This is also kind of a vital instrument. Actually, not really. So this thing has a G meter in it. It's pretty cool. That's a pretty good piece of information that'll tell me when my wings are going to fall off my airplane, because we only tested it to about probably 2 Gs, maybe. It looks so cool. It's like the ultimate desk toy. I bought a bunch of these multi-weave flight controllers. You used to have to buy an Adreno Nano or some sort of Adreno, solder on an MPU 6050, which is an accelerometer thing. Most of us back in the day took apart a Wii video game controller because it had accelerometer gyroscope. You solder the two things together and make your own flight controller. I actually had to explain this to someone the other day ago. Then they asked me, well, do you have any experience with multi-rotors? So I'm like, I was there when the text was written. So this stuff is super old. It's basically worth nothing. Nobody messes with this anymore. So I have a whole bunch of these chips. I don't know. I'll see if you guys are interested and maybe comment something. But I might actually assemble a few of these units by hand and maybe sell a few of them. All right, we're going to mount this into the pizza box along with our airspeed indicator. I also have an attitude indicator that I still need to assemble. So we're going to have airspeed, attitude, and altitude. The 3 A's of flight. So we have our altitude indicator. You just input the inches of mercury, so you call your local airport. They give you the AWOS Automated Weather Observation System, and you just put in your inches of mercury there to adjust your elevation. I actually have like an actual secondary altitude that just displays from when I zero it. So that's fun to put into. So that's cool. I gotta mount one of those instruments in here, so I have another display. We gotta do that. I gotta do all this crap for tomorrow. I'm gonna put this in the pizza box. And for flight controls, we have servos. Not just any servos, though. Big servo. Very big servo. It should be enough strong to fly airplane good. Tail is locked into the airplane. It's time to make some of those important soldering connections of my life. I'm trying to limit as many adapters, doohickeys, and things like that as possible. We have one little regulator. You know what? Should I use a different regulator? It's 15 amps. I'm gonna see if I have more name brand regulator. Okay, I talked myself out of using the cheap no-name universal battery limiter circuit. And we're going with the Castle Cremations universal battery limiter circuit, which is just a 5-volt regulator. Supposedly high quality one. Do a lot of amps. This thing is about as old as my RC career, though. It's been around forever. Like these guys have been making these things. They're known for as being Castle Cremations, is because when their ACs kind of blow up, they really blow up and catch on fire. Sometimes setting your airplane on fire. But this isn't a speed controller. This is a battery regulator, so no high amps. So I'm doubtful that this is going to catch on fire. And the reason I'm soldering most of these connections is because I'm trying to reduce as many plugs as possible, at least for the high-powered things, and basically the servo's the high-powered thing here. Okay, let's do a test. We have the two separate systems. I'm gonna make sure they actually work together because I never turned on two Express LRS receivers to. No, that's a lie. I did that in the VTOL. So I know they work together, but I need to make sure these ones work together. So we're gonna turn it on, wiggle the control surfaces around, move the motors, and then we're gonna turn this thing off and see what happens. These things should stop running because I set the fail-safes to make sure they don't turn off, because that would be a very bad day if I drop my controller or I pass out from my pure excitement and somehow break the radio and the plane just keeps flying away with me in it. That's on. It's waiting to connect. Okay, let's check the motor. Put the two batteries into series, and that series connection goes into parallel for the two motors, or two speed controllers, and then they make this noise. Whoa, shit. Something blew up. What did I screw up? Well, that's bad. Did I really screw the polarity? Nuh-uh. Am I that stupid? I did screw the polarity! Ah, you idiot! Ah! Oh my goodness. I got the two polarities mixed up. That just shows you the power of these LiPos. They immediately severed the connection and just blew the connector apart. See, that's why I put on my safety glasses where I plug this stupid stuff in. So that's no good. Luckily I have a whole extra set of batteries, so I'm not too concerned about that. But I will probably have to change these out, because like, I don't want to mess with them now. What about the other side? Did I screw that up? Nope, that's done correctly at least. That's such an idiot mistake. Like, you do that once and that's it, usually. Alright, that was like 45 minutes later of stupidity and resoldering because this little idiot right here didn't bother to check the polarity of these connectors. So now the stupid gray wire is the positive one and the black one is the negative one. Now we can plug this piece of crap in. Oh my goodness, what a waste. I actually destroyed one of my $200 batteries too. It's crazy. Like, it's internally dead now. Something blew up inside of it. That's correct. That's correct. Here we go. It's in all the way. Okay, I think that's the arming. There we go. That's crazy. They're both turning exactly the right way. That one has the arrow that goes this way. This one's going the right way. So that looks good. Alright, let's check the other side. Watch your nuts, Dave. Works. Pretty good. I can solder this, then we do a failsafe test where I purposely turn this thing off by pulling the batteries out and making sure that the motors stop and the tail holds its current position. And then we should be good to go. Running. That looks good. And I'm gonna turn this off. Okay, that's good. That's what I wanted to happen. So that's good. The other one went no pulses, so I have to set the failsafe up on that other one. Because you can see one elevator is locked in and one elevator is like on the ground. Which isn't exactly what I want, so we'll have to change that. But we'll turn this back on. We're back. Our glorious 3-pack. It's not quite a 6-pack like you'd see on a Cessna, but we have airspeed, attitude, and altitude. So that's cool. We have to interface it into my old dinner. So now I'm gonna cut some. Ooh, still smells like cheese. Hot. Oh, I really burned myself good with that. You know, it's funny. I built that entire airplane, not a single cut, scratch, or even paper cut, or glue burns or anything. And now building the instrument panel, I burned myself pretty bad with a big glob of glue from this stupid thing. Oh, that's gonna waltz up for sure. I made cheese kind of pizza box experience.
Ooh, it feels like it's going forward, man.
Yeah, it's going forward right now, but once it gets in place, it's gonna.
Okay.
Don't let go. It's gonna go backwards though once it actually gets in position. Yeah, that's like perfect. Okay, that's very good. Alright, 3 weeks of work, all out in the field. We finally concluded with all of our builds and we've done the center of gravity check and it all checks out pretty good. The only thing left is to put all of this hard work together in the field. This thing is still cardboard, but it's probably 96% cardboard now, maybe 97. You can still see the plywood in the wings, but who cares? Pick up the wing a little higher. But it's going together pretty smoothly. It's time to ratchet strap these wings on and finally prep to take flight. This plane is obviously a giant shipping box that is going via air freight. It needs the proper labels. So and here's the battery, so you make sure you put the battery sticker where the battery box is. It's tight, right?
I can't really.
Yeah, it's tight.
I mean, they look tight.
When you pick up the tight.
Okay, yeah. It's got some pull.
All right, propellers work, engines on. It is time to get in the airplane. This is going to be the taxi test. First, I'm just gonna drive around a little bit. Then we'll start doing some high-speed runs. It'll probably get light on the wheels. I may even get it off the ground just a little bit, and I'm gonna quickly set it back down. And then we're gonna taxi back, put in the actual batteries. Then we're gonna send it. The plane is now done. It is fully assembled. We are just waiting on weather, and then we can fly. But I should probably answer some questions from the last video.
The early 1900s race car attitude of the body is too small, just put the lever on the outside is great. Your work is always fun.
Funny thing, I thought about that, but we changed that, so now I'm just doing the controls on the inside because it's just, inside is easy, so we're just doing that. So I just kind of cram my arms together and we fly. Okay, next question.
Right now I'm really happy that I live in an era that I can watch some genius guy build a cardboard airplane. What a time to be alive.
I'm gonna get in this supply, we're gonna do it.
For the struts, you might look at cardboard edge protectors, commonly seen on shipping boxes for heavy objects like refrigerators.
I saw that. Okay, that's a good suggestion. If I had some of that stuff, I couldn't really find any shorthand. That probably would have been okay for the struts to actually make them like struts that could take the load. But we had the Flying King post thing, and it's pretty light anyway, so.
As you said here, glue is stronger than cardboard. It's stuck to. Glue holds the top layer of one piece of cardboard to the top layer of another piece, and paper easily delaminates. You really want to use fasteners that go all the way through the cardboard to hold pieces together, then use large washers on both sides. Even zip ties are better than.
When we could, we would have done that. But the problem is, the whole thing is cardboard. Your fastener to grab onto this fuselage would have to like go basically to the bottom of it. Which is why we did the tape slings. Like, that's the whole point of the tape sling, is it actually wraps around, and now the tape takes the load in case it lets go and breaks. So that's kind of how I got around that. And we definitely did that in some parts, like the tails mounted with screws. The screws go straight through the cardboard, have a big plywood washer, and they anchor into the wood. So that's pretty sturdy.
Have you ever read The Flight of the Phoenix? A RC designer and others re-rig a crashed plane to fly themselves out of the desert. This is giving a lot of the same vibe.
It will fly, trust me. I work for a company called Sizemore and Pratt. I watched that movie so many times. This isn't really a Phoenix because it wasn't really built out of anything, but that movie was definitely a good one to watch. Both of them. I saw the one with the C-82 Packet and the one with the C-119. You should check them out if you haven't seen both of them. Crazy thing is, the first one, they actually built the plane in fluid, and then it crashed. I think it actually ended up killing the stunt pilot. So that's kind of nuts.
Not trying to set a record, the plane itself is a record.
It's only a record if it flies. Speaking of flying,
Don't pull on that, you will rip. He's like Charles Lindbergh, how he has to stick out the side to fly, see the plane.
all right, hand me the radio.
Alright, transmitter.
All right, seems okay. All right, the plane sucks, and it's mainly because of the wheels. The wheels have a lot of rolling resistance in this grass, so I might have to tweak it a little bit. I might have to go, I'm gonna go to the edge of this cut grass where it's real smooth, and we're gonna try from there. I'm also going to put the nicer set of batteries in, because right now it's got a weaker set, so they're not as hot. So hopefully that's enough to fly, because I was at full power, and it started to get light on the nose once I got it up to some speed. I was pulling back a little bit, but it wasn't just fast enough to take off. I want to try to fly this time. Actually, hang on. I'm going to take this off. I'm going to try to be as light as possible. I'll lose some weight here.
You just reverse it.
Jacket, okay. Helmet, yeah. Call me when you land it. We'll pick you up.
Alright, I'm going to go.
I got you, wheelie.
I saw that. What now?
You got a long rope?
Well, that didn't really work out. The plane's a little underpowered, and mainly it's these wheels. They're just so draggy and they can't really cut through this grass. So I saw this thing online where they tow old aerogliders into the sky to do some training, and basically we can do the same thing here. Except I'm not even worried about it because the sled is firmly attached to the car and I have this pin to release it. I can eject this whole assembly once I get in the air, so we're gonna use the car to give us a little bit of a boost, get me airborne, and then I can kick and release the sled, and hopefully just fly away.
All right, start moving.
I'm gonna speed up. Keep going faster a little bit. Alright, he's off, Oh, there go the prop. No way. Oh.
It's wow, just a little bit. The undercarriage released though. I was kind of kicking it a little bit.
The prop just broke, but I think that's all that happened. Other than that, it was fine. Felt pretty good. We got off the ground. It felt a little tail heavy, so I might need to put a little more batteries in the nose. But other than that.
You can't park there.
Alright, I'm gonna see this video.
Let's go again.
I might need ailerons. Oh, the freaking lady, the thing stayed attached. That's what I was worried about. Okay, I was like kicking it and it felt a little funny and then it came off and then I wasn't compensated for that enough and I got let it get too slow and it just kind of came back and touched the ground. I think I'm gonna have to try it again. Oh wait, I have a better idea. Okay.
What's the British Molly?
Well, there you have it, dear viewer. We've built the perfect Red Bull Flugtag machine because it barely flew at all. Just kidding, this is not good enough for me. We have to do this again because this plane can definitely fly. I just have to do some quick improvements and then we can actually try this again because I want to go further, farther, and faster. But make sure you subscribe so you don't miss that video, which is coming very soon.
Yeah, that's fine.
What the shit? Why is it all wet? Where did this water come from? Oh god, they're all wet.
No. This is not good. Not good.